Okay, find the gradient and the y-intercept of the following straight lines. Now, we've got our equation of a straight line given in this format, and we're asked to find the gradient and the y-intercept. Now, the plan here is to get it in the form y equals mx plus c, because when we know that, when we get it in that form, we'll know what the gradient is, and we'll know what the y-intercept is. So here I've got 3y minus 9x equals 3. My first plan, I think, is to take that minus 9x over the other side, so it becomes plus 9x plus 3. Secondly then, I want to get y equals, well this is 3y equals, so to get y on its own, I need to divide through the whole thing by 3. So if I divide that by 3, I just get y. If I divide this by 3, well 9 divided by 3 is 3. And if I divide this by 3, I get 1. So my gradient is 3, the value in front of the x, and the y-intercept is this here, 1. So, okay, we have 0 for x, 1 for y. B then, well, in this case, I'm thinking, let's take that minus 3y over to that side. So it becomes plus 3y, yeah? So I start off there, so take that over, it becomes plus 3y. Take the 4x over the other side, so it becomes minus 4x. And then we've got this plus 6 here. Again, just like before, we need to divide by 3. So then this just becomes y. Divide this by 3, this term by 3. Well, 3 doesn't go into 4 perfectly, so you end up with minus 4 thirds x. Divide this by 3, you get 2. So in this case, the gradient is negative 4 thirds, the value in front of the x, and the y-intercept is 0, 2. Okay, so let's look at this one. So in this case here, I think what might be easier is if I take the minus 2y over that side. So we've got this. That would be easier, wouldn't it? Okay, take it over that side, becomes a positive, and then divide through the whole thing by 2. So if I divide that by 2, I get 7 over 2. Divide that by 2, I get 3 over 2, and I get y there. So you've got it like that. You can write it the other way round if you prefer there. Okay, so you've got then your gradient, which is negative 3 over 2, and your y-intercept, which is 0, 7 over 2. Okay, and we're done on that. Okay, so let's look at some tricky ones. Let's look at this one here. Okay, now what I could do with this one, all right, because I got a fraction here and a fraction here. Okay, it's like trying to solve here an equation with fractions, okay, algebraic fractions. What I can do is, because when you've got two fractions, okay, you could scale both fractions so that we've got the same denominator. Okay, I often find that's useful at GCSE. So if I do this one here, scale it. Now scale it up, make it larger. Let's think of a number that 3 goes into and 2 goes into. So if we think of multiples of 3 and multiples of 2, well, 6 springs to mind, isn't it? We could change this to 6 by doubling. We can change this to 6 by tripling. So in this case, if I change that to 6, well, I've doubled 3, haven't I, to get to 6. So that means I've got to double the top. So I get 2y here. The bottom there, I need to triple that to get 6. Times it by 3, that gives me 6, so I've got to times the top by 3, so I get 3x. Now, what you find is, if you do the same to the other side, okay, make that so it's out of 6, it just becomes so much easier. Now, at the moment, it's not a fraction, it's just out of 1, isn't it? Because it's like 1 divided by 1 there. Okay, so you can write it like that, you can write it as a fraction, but to change it to 6, I've got to times it by 6, which means you times the top by 6. There's a minus there as well, so that's the same as minus 6 over 6, yeah? Which would just be minus 1 anyway. Now when you've got 6's on every fraction here, on both sides, you can just cancel them out. So we end up with 2y minus 3x equals minus 6. Get it then, so I got positive 3x, take it over. And then all I've got to do then is divide by 2. Divide that by 2. So I get my gradient to be 3 over 2. And my y-intercept is this value here, okay, minus 3, okay.